Welcome to Push2PROD and to talk about container-driven cloud journey towards an on-prem product. Today's talk will be held by Jochen Mader and me, Evgeny Machnovetsky. Let me introduce myself briefly. I'm a technical product manager within Instana and I'm responsible for the on-premise product. And Jochen is part of my team, the enterprise team. We both have background in consulting and we come from an enterprise environment, so we know what customer needs in that regard. So on-premise is about enterprise, and we will see in the next few slides why. On-prem is hard, and everyone who tried to build a product that needs to run on-prem would face the same challenges we are facing. During this talk, Jochen and me will walk you through the journey we made since the foundation of Instana. Instana is a SaaS company, but why is this relevant? It is because it defines how we do product development. We have fast release cycles, we choose the tech stack that fits our needs best, but this talk is about on-prem product, right? And if you think about a customer in demand for on-prem installations, you might think of heavy industry and heavy enterprises like telecommunications, banks, insurances, and public offices. And you would be right. And why are customers choosing on-prem? And there are three major drivers. First is regulations. So customers depend on governments that put regulations on top of them and require them to keep the data on their own premises, to keep data redundant and safe from the outside world. Second is data ownership. So data itself is a value, and customers sometimes, especially enterprises, don't like to give their data out of hand to a third party. And third is data privacy. We know all the GDPR discussions, and this one is very important to customers, so they can keep the data private on their own premises and do not have to rely on or sign a specific contract with a third-party vendor. Instana was founded 5 years ago, just 2 years after Docker was founded. The first try to ship the on-prem product with Docker failed because it was not widely adopted within the enterprise, and we also discovered that there are some missing features in the early days of Dockers that hold us back from shipping it on-prem. We learned it the hard way by facing a big backfire from the early customers and struggled with the missing features I just mentioned. So we switched to packaging all Instana services and databases into RPM and Debian packages and orchestrated the installation with the Chef cookbook. But as you can imagine, the architecture of a product will evolve quite heavily over time. And we went through countless database migrations, introduced new services, and removed all technologies, trying to keep all the historic data for the customers. And after 4 years, we found ourselves entangled in a solution that is hard to maintain, to support, and even harder to QA. Remember that we use the tools that fits our needs best, right? And this introduces high complexity. And we expect our customers to operate Elasticsearch, Cassandra, ClickHouse, Cockroach, Kafka, and more than a dozen other Instana microservices. But are we doing this hard work for fun? Of course not. In the end, we want to make money with this. So the situation we experienced during the last 5 years was the following. The number of customers grew significantly. We went from 1 to over 80 customers in 5 years that are running on-prem. The revenue grew even higher, but the support effort to get these customers up to date to the newest versions resolve their daily issues grew even faster than the rate of customer growth. So we needed a project that brings the support effort down, and that's what we accomplished. For us at Instana, the customer is king. So we listen, we try to get down to the root problem, and we want always to solve the problem of the customer and never let him alone in a situation where he's dissatisfied. No matter what difficulties we faced with the customers in the past, we always managed to overcome those and satisfy their needs in that situation. So you end up sometimes in a situation where the customer is playing around with the internal configuration, and there are many reasons why customers are doing this. Some are that they have some special use case that they want to adopt. Some are that they need to follow some regulations or just think that that's the better way of doing things. We need, of course, to have a more or less strict policy on the configurations of our files because we can't let the support cases out of hand and need to provide the best-in-class support. And in such cases where customers fiddle around with internal configuration, you sometimes end up finding yourself trying to find a solution several hours or sometimes days, and then facing yourself with a situation where you the root cause comes from a misconfiguration where the customer didn't had the information we had during the creation of the service. Another dimension, and that's after the results, we talked to customers, we worked with them tightly together, you come to the realization that the customer update cycle never matches your release cycle. And since our SaaS release cycle is bi-weekly, and that's really, really fast paced for an enterprise customer, they all have their own speed of running updates. And that came to a problem because the package-based installation was not ready to have a safe upgrade path from any version you can imagine. It was only tested one version back, and once the customer missed a update window, release window, he was basically left alone and need some handholding to bring it back to the newest version. The package-based installation required manual configuration with every release, with almost every release. So customers growing, maturing with the Instana solution, also demanding for automation. So they want to automatically deploy new instances. They want to automatically run updates. And other customers that are like really advanced, that are going to deploy your system as an ephemeral service. And they expect your system to be able to tear down seamlessly and then to bring it up afterwards with no problems. Since you need to acknowledge that a monitoring solution is not a stateless service, this is quite a challenge. And we tried to address it and we managed to satisfy the customer demand. Another dimension in complexity that comes into place is that you're not alone. So it's not only that you're changing the architecture and that the product evolves, you're also running in an environment where third parties change the circumstances your software is running. So there are AWS that brings their own operating system like AWS Linux 2 out, and customers starting to demand for that one. There is Red Hat that brings out a patch for Red Hat Enterprise Linux, and just break systemd where for Cassandra. So a known issue, but we ended up fixing this for our customers because we needed to solve this fast. So there is a kind of, you see, it introduces a kind of complexity just because you're out and the environment around your software changes heavily. Common problems we faced with the old package-based installer is that it's hard to clean up after the component's end of life. So every operating system puts the data in a slightly different way. It's some customers misconfigured their environment in a way that it was really, really hard to bring them back, and they could not provision a new virtual machine. So we ended up removing each component manually, which was heavy effort and really, really tedious for us and painful for the customer. Sometimes you just want to start up fresh, but you don't want to go through the whole process of creating a new virtual machine. Remember, not all customers and not all users are running on a cloud environment. Some, especially banks and insurances, have their own data center, and it's really hard to get new hardware. Over the time, it grew like with the number of customers and with the number of operating systems we needed to support, the number of services, the number of features that we introduced, and the diversity of databases and technologies we introduced into the product, the QA process was growing more and more painful. So there are two reasons why this happened. One was that we didn't share artifacts with our SaaS environment anymore. We needed to repackage all the software, and if there is a specific hotfix that came out for our SaaS environment, we needed to undergo a full QA cycle to get it on-prem. Sorry for that cat. And basically the QA process was really was so painful that we ended up with a situation where we only could release once a quarter. And it was not even predictable. So it was not that we could say, okay, we release once a quarter. It was really, we skipped releases, and then it took an unpredictable amount of time to go through the whole release cycle process, the QA cycle, and get the package out to the customer. Basically, it ended up in a situation that was unbearable for our customers and for ourselves, and it had a really bad business impact. So 2019 looked pretty much like that. We ended up in a situation where the customers were dissatisfied. We had a super inefficient process of release cycles. We burned a lot of engineering capacity for that. We had a high effort for support, not only for our customer success team, but also from our SRE team that is busy all the time keeping the SaaS environment running. So it was only possible to run this on-prem offering with highly skilled people, and it was really, really hard giving it out of hand to the customer. So now Jochen will go deeper into the details what we did to accomplish the solution, and I will just give a few words on, and we'll give at the end a few words about what we accomplished and the customer satisfaction voices. Over to you, Jochen.
Hello everyone, my name is Jochen Mader. I'm a member of the Instana engineering crew, to be more specific, of Team Enterprise, where we are working on the next generation of self-hosted on-premise installations. I'm taking over from Evgeny, and from what you've just heard, by the end of 2019, that's basically where we started, we were facing some crucial decisions to make. First of all, we had been pretty successful with selling and maintaining on-prem installations to customers. The problem was that the effort on our side was starting to grow to a point where it was getting unsustainable for our whole organization to do this for the near future. So we had to reevaluate our whole approach. The key thing to figure out was if we actually wanted to continue doing this. And I think this is just what Evgeny has proven, that with the amount of customers we already had and a well-filled pipeline, we would have customers for years to come who would still want to spend quite a bit of money on Instana being run on premise. Now, the question is, so what is actually the problem here? I mean, Evgeny already mentions that like we were running through a bit of trouble. And I guess many of you already have gotten the cringe from thinking about having to run software on premise, not under your direct control, especially for a company with our DNA. Well, speaking of our DNA, Instana is a SaaS company. That means we're a startup providing a service to customers that is completely under our own control, which means you buy a license for Instana, you download a few agents. You just download one agent and install it on a few machines. And these agents will start streaming data into our system to be there, crunched, processed, stored, and displayed for you. This makes it actually very easy for customers to use our product. So why would a customer want to go the direction of a self-hosted environment? Well, let's just say the world of enterprises has a lot of different ideas of reasons to require them to run their stuff in-house. With in-house, and this is actually why I'm just constantly switching back and forth between those two terms, on-prem and self-hosted, is that like in classic situations, on-prem would mean to be run in your own data center, which is not the case for most of our customers. Most of our customers actually are hosting Instana in AWS, GCP, Azure. Some of them are really hosting them in their own data centers, but I would say the vast majorities of our customers are just simply want to retain data ownership and have everything we do under their own control run by themselves. Now, as I said before, like many of you probably have already like some goosebumps coming up with the thought of running a system on premise. Now we're not talking about like running a database on premise, which is already quite the task. We're talking about Instana, with Instana, and also being like a startup with a lot of playful people in it, having tons of different databases to be run, and this isn't even all of them, on premise. Lucky for us is that we've learned quite a bit about these databases. First of all, we are running our own clusters in SaaS, in our own SaaS. That means that we know how to operate them, we know how to scale them, we know many of their kinks and problems that they bring, and we know how to upgrade them and maintain them. This was basically a rather conscious decision taken in the beginning of Instana, so we are flexible to move between cloud providers. Yes, we actually are right now a multi-cloud company by running our SaaS inside AWS and GCP. But the core thing is that we know how to run our stuff. And we already had gained a lot of experience by running our whole infrastructure inside HashiCorp Nomad. I hope most of you, at least some of you, know this. So Nomad is like from the great HashiCorp, a great tool that allows to orchestrate and distribute applications across a vast array of servers. Now, to be honest, I still love Nomad, but if we look at what is going on right now, we also see that there's a big move, a big shift towards Kubernetes going on, which also caught us. So currently, we're moving our SaaS over to Kubernetes to be more flexible for the future and to be able to sustain the growth that we are already currently facing. Now, these things combined gave us a very good situation to start our whole on-premise efforts. So this was our basis for actually providing the package-based installation. Now, the problem that we were facing here is that a package-based installation is not really easily maintainable, and that's for multiple reasons. The biggest reason that the biggest problem that we've been facing here is that we lack control. With distributing a ton of different dApps and RPMs to customers, the customer can interfere a lot with our installation, forcing installation of old, outdated packages, forcing parts of our application to use different configuration files, even going so far to replace the database versions that we provide with database versions they see fit. This has caused us a lot of problems, especially debugging becomes one hell of a nightmare. The other problem is that all and every tests that we do for releasing our stuff into the SaaS environment have to repeat it for everything that we want to do over here in self-hosted. Why? Because we have to repackage everything. You can't just if you have primarily pouring containers, you really have to do the whole tests again, because what you're shipping over here has only very few things in common with what you're doing over here. So basically, we have double the QA effort that we actually wanted to have. Then the other problem is that what Evgeny has said before, the customer has to do a lot of manual interventions. Manual interventions are taken for example, getting rid of old components, sometimes even tinkering with configuration files, removing stale information from the operating system. Most of these things were step-by-step automated, but never to the point that we were confident to have a fully automated running system. So we pretty much learned over the past 2 years a lot about running applications on premise and how to actually get this as a customer and the things that can go wrong. We learned a lot, not all of it, and we still ran into a lot more issues and repeated several mistakes that we've made before. Just want to be honest here with you. So we condensed all these learnings that we had into a new iteration. So first of all, well, we remember this. We move this over here. The first thing that is a highly problematic scenario is that when running in on-premises, then we have tons of operating systems. Let's just pretend that these nice building blocks are each one a type of operating system. For us, each of these operating systems has to be tested. So we do QA for these 3 versions. In reality, it's more right now. I think we're around 8 different operating systems that we're supporting the current iteration. So what we have to do is we have these Instana components. In reality, these are close to, I think, 25 or 30 by now, which have to run on each one of these operating systems. Now, with all our testing, we can only cover these. But now, customer comes in. Customer might decide that for their package-based installation, they will rely on a more recent version. Like in our case, this might be Ubuntu LTS. This might be bleeding edge. Might run, might not run. The problem is here, customers simply running on an untested system. You might now still well, they had a license agreement or anything with us. This does not matter in the sense when the customer is starting to pay you money. They will ask why this is not working, and you will first spend a lot of time figuring out what the actual reason is. Even worse, or maybe even better, is when they start running stuff on an older operating system version. This might actually be the happy path for us, because it just simply might cause Instana to not even start up, and it might be easier to discover. Still, very annoying situation. The other very annoying situation is when a customer decides to run their stuff on a fork of another operating system where it's not clear to us like what we're actually running on. These could be caught, most of these, but they take a lot of manual intervention, version checking, and with a lot of packages being deployed, this gets out of hand pretty easily. Which brings us to the next problem, which is not as easy to solve, but we still have to think about it. Well, let's pretend this is the machine we want to run on. Let's now have the customer use this operating system. Let's use this. This is already a tight fit for one of the services. Trying to run another service on the same machine, which is required because what we normally do is single box installations, will cause this machine to collapse, and which poses another problem. Up here, this might be virtualized. Even if we tell the customer to not ever virtualize the whole thing and to make sure that we have enough IOPS for all the databases. And there might be multiple other reasons how the customer is cheating around the hardware requirements we provide. These problems are very hard to discover and very hard to catch. So, this is not really the scenario we wanted to go for. What other options are there? Well, as you might remember, we're already running these two. These two are strictly container-based. Container-based, and although I hope that most listening here already know what our containers are, well, I'll still go a little in the explanations here. I just tell you that like we have to live with customers installing all kinds of operating systems. Well, containers are a great way to get rid of this. Some people refer to containers jokingly as a way to deliver your local development machine to production, which is actually something that we all of us developers ever have been dreaming of. So let's look what we can do. Over here, we already had decided a long time ago to use Ubuntu LTS. All our containers use Ubuntu LTS. We test each container, we add different components in here, and file these components into our runtimes. This might be Nomad, it might be Kubernetes. In all of these scenarios, we have like a few things eliminated as a problem. Number one, we don't have to worry about the version because we know the version that is in there. Number two, we know what kind of tools are installed there. We completely know like what will be available at runtime. And number three, we have easier control of when things run and which things run in combination. So, why didn't we do this in the first place? This is probably like one thing that brings up right now, why we actually went this hellish way of providing this amount of packages to our customers. Well, to be honest with you, we tried more than 2 years ago. I think like about 3 years ago, we tried for the first time shipping Docker containers to our customers. The problem at this time was Docker wasn't there yet. Docker was available, but the enterprise customers did not trust it. There were not enough distributions available that would ship Docker out of the box. Installation was still something that felt handcrafted, and if there's something that enterprise customers don't like, it's the feeling of handcrafting anything. So customers had decided against Docker and sometimes even went to great stretches to make it impossible to run Docker on their environments. So customers basically forced us to go the package-based way to be able to provide them with on-premise. This situation has changed over the years, thanks to a lot of stuff coming from Kubernetes, OpenShift, and so customers realized that using containers isn't actually that evil, and it actually gives them a lot of flexibility that they didn't have before. So we started the second round of our container initiative to get to the point where we wanted to be able to run Instana containerized on customer machines. Question is, how do you deliver something? So, if you have never touched one of these two, the first thought might be to just go with either Nomad or Kubernetes because, hey, we know both of those. Well, first of all, no one wants to take the responsibility for running Nomad or Kubernetes at a customer, especially if you want to have a system of low maintenance. This might be counterintuitive, but like, let's just say that these two only get provide you with the value they actually can provide if run by a very seasoned SRE team. You need people who really know what they're doing there when running these. I would not be confident by shipping a full Nomad installation or a Kubernetes installation to a customer and hoping that the customer is able to actually maintain this whole system. Especially since the focus of this version of Instana installations is on single box installations. So these don't really make sense at all. They would just add a bunch of problems for maintenance. So these are out of the picture. Well, but there are still other options. Or, well, one very obvious options. And this would have been Docker Compose. Well, let's just say we tried it. I like Docker Compose a lot for doing local testing, for playing around with things, and it might even work for deploying certain distributed systems. Now, the problem with Docker Compose is, first of all, we already have a lot of stuff of configuration management in place, health checking in place, update mechanisms in place that work very well out of the box when we're bringing up a system. Now, Docker Compose, while being reasonably flexible, does not provide us with the flexibility that we need to run such a system with a customer. So the other problem with Docker Compose is, and there's another part I need to be open with you, is that it would open things again to the customer. So while we like our customers a lot and we want to make their life easy, many of the customers don't really make the life easy for us by messing around in our installations. By providing a simple Docker Compose configuration, which might even be visible on the operating system level by just getting VI or Emacs up and going and diving into the file and start messing around in there, it's something that we wanted to make as hard as possible. We don't want the customer to change the way Instana comes up. What we want is the customer to tell us when they have to start messing around with the internals of our system. We've seen a lot of cases, and we finally uncovered those, where customers were adjusting values inside the system without us being aware of this. Now, with Docker Compose, we lose this capability to some extent because customers can just sneak in their own containers on that. So Docker Compose was out of the picture. It's a nice technology, but does not really fit what we want to achieve. This brought us to another problem. How are we going to maintain a system, or like how can we bring up a system with a minimum dependencies on the actual package level? Well, I guess you've all heard of Go. Our reasoning to go with Go and not with another language is something that I will explain in a lot more detail in an upcoming blog post, because it would just go beyond what we are here for. But what we actually did is we created an installer that was self-contained, not relying on any piece from the operating system. So it has to rely on operating system, but no shell tools, no dependencies. Now it's like directly talking to the Docker daemon instead of going through the shell commands. Directly changing kernel values without going through other helper tools. We just wanted to avoid to have any sort of dependency. The only dependency our packages now have is the dependency towards a running Docker installation on the whole system. And this is actually the core of our whole thing on how we bring Instana and all the services that we have in there up and going. Well, another side thing that we have to talk about is this one. Well, I'll just make a commitment here and say I actually like systemd. I know that I'm getting quite some flame for this, and I already received some flame for this on Twitter, but honestly, for what we are doing, even like with a package-based installations, some issues with updates aside that happened like when Red Hat switched version and nuked Cassandra with it, we were actually pretty happy with what systemd provided us with. And even right now, systemd is what we use to bring up the Instana core process, which orchestrates the starting of Docker containers, and is used for many other maintenance jobs that we have to run. So yeah, so with systemd and Go and Docker, these are the three dependencies that we need on an operating system to bring up a full installation of Instana. By now, so after working on this now for several months, we started to approach the first releases with it. And we were working on achieving another milestone with now having systemd in place, having our custom start script in place, and also having everything moved to Docker, including the databases that we wanted to or had to bring up in there. It was finally time to think about releasing, which actually posed another great chance for us to streamline our process and how we are working with stuff. In comes Jenkins or AWS code pipeline, or like we use quite a few tools right now for being able to release as fast as possible. You might remember that Evgeny also mentioned that customers weren't not really satisfied with the release cycle. With this kind of pipeline and being able to reuse the Docker containers created for running in our Nomad and Kubernetes environments, we were now able to actually automatically spin up QAing environments, testing environments, and to make the whole releasing process a lot easier. It actually is now at the point where any member of the engineering team could start and work on an on-premise release, press the correct buttons, and have it and make it available to the customers. We basically by now quadrupled the amount of releases we do. Where we had like 3 to 4 releases during a whole year in the old world, we're now up to 12 or even more like more major version releases a year. This whole thing already freed up a lot of people in our teams to work on different things. But after this pipeline finally went live, we had to realize that as much as Docker helped us, or like containerization helped us, to get around the limitations that we were facing with package-based installations, we were running now in issues that we had not anticipated. And I don't think they're actually something that you could anticipate. And I don't want to shield you from these. Actually, I think there are quite some interesting stories. So I'm going to tell you a few of our most interesting disasters that we ran into while rolling this out to our first few customers. So let's move these over here and these out of the scope. The first one is probably is like one of my favorite ones. I call it death by I/O. Well, we've been talking about these containers here a lot. We've also mentioned that there are machines of varying sizes. Well, there's also a big thing about running things on these machines, which is tightly influenced by the way the machine is set up. So let's take a look at this. We normally recommend our customers to do the following. They should have at least 3 disks. This one is for ClickHouse. This one is for Cassandra. This one is for all that's left. Now, let's just say customers don't often, not always, follow what we tell them to do. What we hadn't realized is that several customers were sidestepping our requirements for disk sizes. So while we were checking that we had the correct disk size and that we had different mount points, what we did not realize, did not check is that the customers should use dedicated disk instead of just partitions on the same disk. So what customer did is there's now 1 disk. We have Zookeeper. We have Cassandra. and we have ClickHouse. Now the issue is that when our customers migrated away from the package-based installations, we had to do a lot of data transformations, which were mostly based in Cassandra. The results of that was that Cassandra turn around. So, well, sorry, I have to explain first. The customer was basically placing these 3 servers and everything else on one disk. What happened is Cassandra came up first. Cassandra started to work and gobbling up every ounce of I/O available. So what Cassandra did actually, first of all, it got everything from Zookeeper. Now Zookeeper is very patient. Zookeeper will just continue to work. It will emit a little warning that says, hey, I took way longer than I had expected to flush this snapshot to disk. Something that we overlooked and actually didn't have in our log files. Our bad. Over here's ClickHouse. Now, ClickHouse is heavily reliant on the Zookeeper for handling certain types of tables. ClickHouse came up and ClickHouse was trying to talk to Zookeeper. But ClickHouse has a timeout for the session it has with Zookeeper. What happens is the session times out. ClickHouse is in there, has the opinion that Zookeeper is gone. ClickHouse stops working with a weird exception. It took us several days to figure this one out. Well, our team is not like SRE specialists, we're slowly turning into those. But it took us a while to realize that what actually was happening is not a failure on the ClickHouse side, but like the choking of Zookeeper. The lesson learned for us was we are now verifying first like what disk we're running on, and we're starting to run more in-depth tests on like the amount of IOPS available on these machines to figure out if we're actually able to run and do our stuff on that. Well, but things can get even more exotic when running stuff in on-premise. I just talked, so like we have to get back to these boxes again. We have the operating system under our control. We have our services under control. With our additional checks, we even have the hardware somewhat under control. What I haven't talked yet about is the kernel. So, well, the kernel is basically a shared resource between all these containers. So what we do is, with the hardware running, well, my bad, still have to add an operating system in here. We have some operating system in here. Below the operating system, actually, yeah. On the, the kernel is part of the installed operating system. Our containers share this kernel. That means all kernel settings up here affect all these down here. Well, this is common knowledge, isn't it? The problem is just the amount of available kernel tuning settings in there. Using the Linux tools, you can set, I'm not sure, I think more than 1,000 values in there. Most of these you should never touch and are already set at very safe defaults. There are some that are touched commonly, like TCP related settings or other settings that I'll go later on. But there's like one setting that I had never touched in this way before until a customer reported problems. So what happened? The customer reported ClickHouse was dying. And then Cassandra was dying. Next, Zookeeper was dying. And random iterations. We had random services just popping back and forth with no indication on what was actually going on. We spent a solid week of debugging what was actually going on until we discovered a certain setting the customer had touched that we did not verify to not be touched before. And it's this beauty. proc sys VM overcommit memory. Some of you might have seen this setting used in relations to certain databases. So the different values are 0, which basically says the kernel can overcommit and will overcommit, but it will use some heuristics and statistics to actually decide if enough memory will be available in a near enough time to be provided through the service. Well, this is basically the safest setting. This one, people running Redis might have seen this, is just overcommit, don't check. Well, it's just grinding out this it's a small bit of more performance that you can get from such a system, and it's actually a also widely used value. The one I've never seen before is this one. So now, well, and here like the pest comes in. This setting basically results in the combination that customer set it that the kernel would provide us with memory. That memory was not free yet, but instead of giving us an out of memory, and this is actually the only way I've seen ever this being used, instead of giving us an out of memory, it will result in page faults. This is nasty. When you see your application request due to page faults without knowing that this setting has been set, there's a multitude of things that can go wrong without actually ever coming to the conclusion that it was a kernel setting. So, lessons learned for us. The kernel is more vital than we thought. What we started out with was just like when we built our containers to set the values that we knew we had to set. What we did not do is verify that all other values in the kernel are at some sort of reasonable default values. And I want to be honest with you, we're still not there yet. The problem right now that we're facing is that these values can be manipulated in tons of different ways. The only thing that we can tell customers is that we check for certain default values and save defaults or like against the values that we know. Well, the problem is the customer can always just manipulate the kernel up here. This is something the containers will not protect you from and where you have no chance of catching this. Now let's come to the last part of my horror story cabinet, ulimits. And this is another problem that we've encountered several times now with Docker containers. The core problem here is that ulimits, as you expect them to work, are set at a top level and are then brought down to your users you're actually running in. Now, with Docker, there are multiple ways, and distributions handle this quite differently. Like, for example, we found one distribution simply hiding, setting the ulimits inside the service definition of Docker, instead of defining it for the user or defining it on the operating system level, which basically overrides any value. Like, remember, like most of the time, Docker daemon will run as root. So what happens is, if you try to impose a certain limit, it will be ignored by Docker. So this is not like, normally you don't want to actually reduce the amount of open files, what we're handling here right now for Docker, you want to increase it. The problem is if a fixed value has been entered, as we have seen at multiple distributions by now, this means that aside from editing the actual system unit, there is no way to getting around these files. And that's it for our horror stories. In general, our learning has been that the move to using everything, to actually using the containers for deploying and shipping Instana to our customers has been the best decision we've made so far for on-premise. It enables us to have a seamless upgrade process. It makes installations air-gapped, like where the customer has no direct connections to the internet and where we actually have to ship things, a lot easier by having a predictable way of extracting a complete version. And with our systemd unit that we ship to the customer and our custom Go-based installer, we are able to very tightly control the environment. So far, the customers have been very happy about this, since we incorporated all the hackings they've done into our system and opened that up to them. Like as I said, like we don't want to lock customers out because we want to mischievous to watch them. It's about having a system that's still able to run. Right now, we've gathered most of these informations. We've talked to most of our customers about this, and we know what's going on in our systems. And this has resulted already in a huge drop in issues that we see in our system, and a lot of testimonials coming from our customers that tell us that they are very satisfied with how we have actually tackled all the problems that have come up in the past, that we managed to actually bring everything into a decent migration path, especially like doing such a huge technological shift from having the package-based installation completely taking over data into the new world. And that we even were able to crunch out quite a bit of more performance from existing systems. The best part for me personally was that even our SRE team was so convinced that they see that all effort they had to put before into the system has gone, and that we went from having to support this with 2 people on full time to down to like now having this part of a team effort. Now we are happy about containers. The move there was a tremendous door opener for us with several customers, and we expect to make a lot more business in this area. What's coming up next, and this is going to be even more interesting now with all the experience that we've collected there, is that the next step is going to be the big one. And the big one is going to be a Kubernetes operator. And I hope to be able to tell you about this venture next time we see each other. Thank you a lot for your patience, for listening to this whole thing. And if everything has worked out, I can give you now a short demo about how Instana is actually capable of being brought up. Actually not, because I destroyed the recording, I just realized. So we will see us in the panel meeting. I recommend checking out Instana. If you want to know more about how we can run stuff on premise and how this works and our learnings for the future, just follow our blog, follow us on Twitter. See you next time. Goodbye.